Now, I'm a fairly big proponent of the idea that certain programming topics are best taught by discussing the low-level fundamentals rather than the high-level API, in the same way that Dan Abramov teaches Redux or Francis Stokes teaches just about anything. Today, we're going to discuss a fairly hip JavaScript topic, reactive data structures. This is From Scratch, Episode 1. Now, for the most basic of use cases, let's try to share data between modules. Now, normally when we do this kind of thing where we want changeable data, not constants, we do what's called prompt drilling in React, where we have a parent have access to the data, it passes the data to its children through references, and its children request changes themselves. But again, prompt drilling can get a bit messy because you have children of children of children requesting data changes, and all of this has to get passed up to the parent. And this happens over and over again. It's a bit of a frustrating system to work in, so we're going to avoid that entirely. So let's just see how our code sort of looks. We're going to be dealing with a high score of sorts. In our data.js file, we have our score, which equals 0 at the start. Our buttons are importing that. They're incrementing them or decrementing them. Our index.js file is importing that module. It's getting the score as well, and it's displaying it in our h1. Our index.html is going to be importing the index.js file as our main entry point. And so if we click the increase score button, nothing happens. We do get an error in console though. You keep pressing it, and over here, same sort of error. Assignment to constant variable. Now, this is because our data.js file is exporting a primitive. Now, you might say, oh, well, it's const. That's, of course, why. If you change it to let, we get the exact same response, though. Assignment to constant variable, but it's not constant, it's using let. Now, this doesn't actually do what you might think it does. It only allows it to be editable locally, meaning if we created a function called, let's say, increment, we could do score plus plus, and we could actually call this function from other modules, and it would in fact change the score's value over here, which is a bit interesting, but doesn't really help us, and it's a bit more messy than we'd like it to be. So we want a way to be able to edit the value in data.js. Again, we could just import some function called increment and decrement, but then we couldn't, give it a custom value like 46. So the easiest way to solve this problem is to make it an object. Because again, the problem is the fact that it's a primitive. We can't assign to primitive values that we export, but we can assign to values of objects. So let's just git stash over here. And then git checkout. This is a custom little system. We'll see if this works. And we just change it to an object with a value property. Score has a object which its value is 0. Button is going to be incrementing score.value and decrementing score.value over there. Index.js is going to be displaying score.value. Now, if we just try this out over here, we click increase score. No error, but nothing's really showing. And we are actually increasing score.value and decreasing score.value. So why aren't we seeing any changes over here? The reason for that is because, well, in index.js, we're only setting it once. Well, what we could do as an easy solution over here is every 20 milliseconds, we're just going to redisplay with its values over here. And this, of course, does work. But this is every 20 milliseconds. We're calling our code when we don't really need to. This is a lot more work than we would like it to be. And if we have multiple sorts of areas with data like this, then we'd be setting it every 20 milliseconds, doing a lot more work than we need to. What we want to do is just change it whenever the score changes, not just arbitrarily change it and hope that it catches when a score actually does change. To do this, we need to change to a bit of a different system. Let's dash and change to version 3. We need to change to a system with subscribers, sort of like a newspaper, where if a value changes, we get notified, if of course we subscribe. So we created something called Reactor, where we created a reactive data structure. In data.js, we're instantiating it with new reactor with the initial value of 0. Let's just see how this works. We're in the constructor, setting the value to _val, which is our private variable. We're creating an array of subscribers, people that want to be notified when we change. We're creating a getter and setter. So before we had an object with a value property, over here it will seem very similar to people, and in fact our code in buttons.js has not changed at all. It's the exact same score.value. However, this isn't really a property, it's a method, it's a getter. it's disguised that way. And we're doing this to really make the code look a bit simpler to the user. And instead of having a set and update method and a separate get method, we're just going to have getters and setters. So we return the underscore.val. For the setter method, we take the value, we set it to underscore.val, but then we loop through all of our subscribers, people that want to be notified, and we tell them that the value has changed. To be a subscriber, you just add a function to our subscribe method, where we just push the subscriber, and then we call the subscriber immediately. This seems unnecessary, but it will be super important later on, and actually does have a bit of a convenience. Now, in our index.js file, we're calling score.subscribe, and we're passing it the function where we retrieve the value, and then we're setting it to the h1. Now, this is not a set interval, but if we increase the score, look at that. You get notified instantly. Not 20 milliseconds later, instantly. And we're only running when we need to. So we could kind of stop the video here. This is a reactive data structure. This is how they work. This is why they're fantastic. This is why they're super usable. But we haven't really got to the crux of the matter yet, because reactive data structures are a lot more powerful than this. Let's take the example of having computed values, which is basically a reactive data structure that is reactive based on another reactive data structure. Now we can create another reactive data structure and have its value being changed, but let's say we have a bunch of high scores, and we want a high score. That might be a better example to think of. So we have a bunch of scores. We want one high score to be dynamically changed whenever a score changes in our array of reactive scores. So let's just go over to the other branch. Let's do git checkout o3-problem. Now, let's look at our code over here. Reactor has not really changed, same code as beforehand. In our buttons.js file, actually, let's go to data. We have a scores, which is a reactor of an array, high score, which is a regular primitive value with a reactor, and we're exporting a function. Add score, you pass in a number to it to add one to this array over here. It creates a new reactor value with that score, so score equals new reactor with that number. It subscribes that store to our setHighScore function, and then it sets scores.value equal to the new array, where score.value, comma scores. We don't use scores.push, by the way, because we need the equality to call the setter. Now, in the subscribed function, we're kind of looping through our entire scores array, and we're setting the highest score to the highscore.value over here. Pretty simple stuff. Now, in our buttons.js file, we're going to be calling add score with a random integer between 0 and 50. And for the change score, we're going to change one of the random scores to the new value. Now, if we do this, it actually does sort of work. It's a bit messy, but it does work. If we hear it's 28, and it changes. Right, based off this big little function over here. But we do have a problem over here. If we click change a score over here, this is over here is changing. We're seeing high score change whenever we change a score. The scores isn't changing. That's kind of weird. Why not? Well, whenever we click change a score in our buttons.js file, we're changing a random score, and each score over here is a reactive value. And when a score's property changes, it tries to reevaluate what the high score is. But the scores array itself has no idea that a value inside of it has changed. So this over here doesn't in fact update. We can change that by making a bit of a scores.value equals scores.value thing. It's a bit weird, but it does actually work over here. You can click add scores, and then this changes now. We click change a score. So this is all fine and dandy, I guess, but it's really messy. And there is a much better way of doing things, where we can actually change a score inside of our scores array and have the array know that it has changed and therefore update itself. We're going to have a much better example in a second over here. Let's do git stash, and then git checkout 04. We're using something called a computed. Now, a computed is a new part of our library we're going to discuss in a second. And what a computed does is it takes other reactive data structures, in this case score1.value and score2.value, and it returns a new value to that. So we have math.max to get the higher of the two values. And we have an example over here, right? Score is 0 to 0, high score. Increase score 1, high score changes instantly. Change score 2, and then once it gets higher, it changes as well. Now, this seems a bit like magic to me. I don't know about you guys, but this seems crazy. How does this computed value know to update based on score 1 and score 2 changing? Now, you might think, oh, maybe perhaps whenever any value in Reactor changes, it updates computed. But it doesn't. They're actually separate functions. We can create a third value, a third reactor, and that can change, and this will never be recomputed. So this is one of the really powerful parts about computed values and reactive data structures. The fact that we can create a new data structure, which is reactive to other reactive data structures. And we see the actual code going on over here, where we, again, don't have to assign high score or scores to this. We have a computed value, which updates the scores whenever any of the score changes. And we have a separate one for the high score. Right? So the computers are really powerful, because again, we don't have to actually return a new data structure, as we did over here. Computed returns a new reactor. But over here, we're just using it for its side effect, to basically change our paragraph 1 of scores. Let's look into the code and see exactly how we made it work. So, the most important thing to notice here is there's a new top-level variable that is local to both of them, to our reactor and to our computed function. This is super, super, super important, because they have to communicate some way, because how else does this work? Again, this looks like magic to me. The fact that you can have this thing, which is reactive to score 1 value and score 2 value. It knows when either of them change. To do this with a local variable, it's initially undefined. We're not setting it to value on purpose. We could set it to null if we wanted to, but undefined is fine in this case. Our computed has to return a new reactive value, so we're creating a new reactive value with the value of null at first. We have a function which it subscribes to, and the function it subscribes to is setting this reactive value to the result of this function. Now, let's look back at our data file to see what that means. We're doing math.max of both of these values. So this one returns is going to be the maximum value, and that will be the value in our high score. Right? And this is what this function subscribes to. We never officially set it, but that's kind of what's going on. We do previous value equals compute function to make sure that we're setting it aside for the moment. And then we're setting compute func equal to this function that we want things to subscribe to. So we're calling the function, we're setting this back, and then returning the reactive value. But we never actually see anything being subscribed in this function, so how does it work? Well, the important thing to know is, again, this is local to both computed, and our reactor class. And when you get the value of a reactor, ever, if compute func has a value, and again, it is usually undefined, as it is normally, if it ever has a value, and the only time compute func will ever have a value is if we have temporarily set it to this when we're running a computed over here. If it has a value, we're going to add that function, which again, in this case is going to be fn, to our subscribers list. And we're not going to call it initially, as we did over here with func. So again, this is very, very important. Compute func is usually empty, usually has nothing. If it ever does have something, and the only case that it will have something is if we're calling computed, and the first time we call computed, we're subscribing everything inside. So let's run through what happens. We call computed. The function starts. We pass in the function to it, which has math.max of score 1 and score 2. Right? Over here. We set compute func to this function over here. We haven't called it yet. Then we call it. When we call it, we're going to set this value to the result of this function. In this function, we're getting the maximum of score 1 and score 2. Now, score 1 and score 2 have a getter. Again, this is not a regular value. This is a getter, meaning we're getting the value, and we're calling the getter over here. And again, this is still inside this func over here. When it's inside them, we're calling that getter with math.max. The compute func has a value. Its value is this function over here, which means that they're all going to subscribe to that function. So whenever either of them change, later on, we're already subscribed to the function which updates this computed value. And I hope that was a clear enough explanation for you guys, because this is a bit of a difficult thing to get at first, so I don't blame you if this is a bit more complicated and you'd like to review the video over again, or the article that I will hopefully link in the description, where you could probably go back and forth. But we're not really done yet, because this is an example where I'm using two values, but the original example I used was with an array. So can we use an array as our sort of reactive value? Well, let's try that. Let's git checkout 04-problem. Now, over here, we're going to add a score, 14, 48, 47, 6, 3. And it did seem to work, actually. Let's refresh it again. 27, 38, 24, 49. So high score actually does change with an array. And we're using a computed again, right? Computed, and we're getting all of the numbers. We're going to spread it into math.max, and we're going to get 0. But the reason why I did comma 0 at first is because when the array is empty, we're going to get negative infinity as the first value. So we did 0 just so that 0 would be the minimum value we can get. In our index.js file, we have the basic step beforehand. We're going to get the array and make it comma separated, put it in our h1. This is the same as we did last time. Nothing changes over here. Reactor, this is all the same. Nothing changes over here either. So let's look at buttons.js file. In our buttons.js file, we're going to, when we click the add a score button, we're going to add a new reactor with a random number, and we're going to add it into our array. And this works. This works completely fine. High score changes, the scores change, but it doesn't work with change a score. Now, change a score is going to change a random score over here to a certain value. That's 46, 46. Oh, that's a fun coincidence. 45, 26. Let's change the score. Now, according to my console, I changed 26 to 32. Right? But none of this is changing over here. Let's change it again. I changed 32 to 28. Change one more time. So 45 to 43. Nothing's changing over here. That's very weird. That is very weird. Now, the reason why this is happening, this is not a surprise to me, is because while we are changing it, this does in fact work. All right, let's comment this out so you don't have to look at my console.logs for a second. We are getting a random index, retrieving that value, and then we're setting that value, right? So originally we had the array be reactive. Here, let's look at the computed value, right? So officially, we're going over all the scores. We're going with the s.value, and we're getting the maximum of it. The thing is, in computed, the reason why computed works, we have to remember this, in a reactor, is when we initially call computed, compute func has a value, right? So let's look at what does the computed look like. When computed is initially called, compute func has a value. When it's initially called, it's empty. So remember how we're saying that every single array inside of, scores.value is going to, when its getter see the compute func has a value when computed is initially run? Well, this array is actually empty. So no reactive value is going to subscribe at all. And we do add more values later on, like with the buttons.js file, we're adding more reactive values later on. But when we add these values later on, they're not subscribing to our function in computed, right? Because we set our computed to only ever, let's just don't save. We set our computed to only subscribe on the initial run. Compute func is only full on the initial run. So how do we change that? How do we make it so that when a new item is added to our array, we are going to again be able to subscribe to that? Well, it's pretty simple. What we could do over here, and I'm going to make sure I don't want to mess this up, so I'm going to look at my code on my other monitor. Okay, we're going to replace this over here, make this a function. Let's set this inside. So we just move the code inside over here, right? So now, inside the function that we're subscribing to, it sets compute func. Right? That's a basic change. Seems pretty simple. All we're really doing is that compute func has a value for the subscription. But we're going to run into an infinite loop very quickly. This is going to be annoying because when I add a score, it's going to stall my monitor. Add a score, nothing changes. That's not good. Change a score. Oh, it's a bit broken right now. But really, essentially, we're going to run into an infinite loop here, which might be... Oh, I didn't call the function. That's why things happening. All right, let's add a score. And probably, yep, buttons aren't reactive anymore. This is an infinite loop. The page is going to crash in a second. And I'm going to explain kind of why while it's crashing, so I get to... can I refresh? It's going to take a while to refresh. So while it's crashing, I'm going to explain kind of what's happening over here and why it is in fact happening. So let's look back at our example over here. If ComputeFunc has a value, we're going to add it to our subscribers, right? Simple as that, hasn't changed. What has changed is the subscribe func, because before we say ComputeFunc is almost always empty. But now, whenever our computed is running, ComputeFunc actually has a value, right? To go to function, and we're actually, calling ourselves sort of recursively, right? And this is actually fun. This recursive isn't too much of a problem. The problem is whenever we're setting a value, like over here, let's kill the page. Let's open a new tab. See, it crashed over there. Infinite loop. Let's open up our console again. So the problem is that when we set the value, so when any reactive value, which again is subscribed to ComputeFunc, changes, we're going to loop through our subscribers. And our subscribers, one of them at least, changes ComputeFunc. And when we're getting ourselves, we're subscribing to that function. So we're looping through all of our subscribers, and one of the subscribers that we're looping through makes us add another subscriber to ourselves. Subscribe func over here, because this computed fills ComputeFunc with a value. When we're getting ourselves, which we do in func over here, we're seeing that ComputeFunc has a value, so we're subscribing to ourselves. And then we have one more thing to loop through. We loop through that. We have the last one, which is ComputeFunc. ComputeFunc has a value. We add it to ourselves, and it goes on forever and ever and ever and ever. A solution to this might not be to use a for of loop, because just use a for let. Let's do like for let I equals 0 while I is less than this dot subscribers dot length I plus plus, right? And let's do const subscribe func equals this dot subscribers I, right? This might work in a way. Oh, it didn't. That's another crash. There's a much better answer to this rather than just changing this loop over here. Let's control Z over here. And that answer is to use, oops, let's just control Z over there. That answer over there is just to use, yeah, that page is going to crash. Got to wait for that. A better example is just to use a set. So we're using an array over here, and arrays can contain duplicates, right? And usually if you add a bunch of functions, you won't really see a set filtering them out. But in our case, we're actually, the ComputeFunc is the very same function over here. So we're actually going to get a, the set is going to reject it. It's a cool little thing. If you don't know about set, I'd advise you to look into it. It is really cool and super useful, especially in our example. We just changed push to add over here. And then we click add a score, and it works perfectly fine. Change score works as well. No infinite loop whatsoever. Now let's just git stash. We're going to change to version 5. So we have some basic cleanup in our values. Version 5. This has changed. Another cool little change I might have added over here. Here we go. An unsubscribe function. Because let's say you are subscribing to it, but you want after a while to unsubscribe. With new set, this actually is super, super simple. We can just do .delete. Usually we have to find the index and then delete it and use splice or slice. But actually over here, we can just do .delete with our unsubscribe function. So whenever we call subscribe, we're actually going to return an unsubscribe function, which we can then use later whenever we want. Make this thing super useful. And that's sort of the end of our tutorial on computed and reactive data structures. I hope this was useful to you. But one area where this might seem a bit even more practical is with the MIDI framework. Things like Svelte and Solid.js actually use reactive data structures for basically everything, including global state, which is what we're using it for. Global state, where state management is passed around, and we can react to it, even though we're not passing it down from a parent to child component, because we have subscriptions. Things like React or Vue might not actually use them for global state. Vue does use them for everything that isn't global state particularly, which is pretty interesting. But let's check out our version 6 to show you how you might use this for a mini framework. With Reactor, again, this hasn't really changed. It's the same old, same old. Oh, I didn't have the unsubscribe. I guess I removed that one over there. Oh well. We have a framework.js file, and what this does is we have a wrapper class around elements. When you pass an element to it, right, so we have to do it sets the underscore L to that element. With append, it will add that element after this element. On will add an event listener to that element. And bind is the really, really cool one. I just want to go over the other ones before I do that one. Get will take a selector, retrieve that one. Create will create a selector, create an element from that selector, and then return it as a wrapper class. Simple as that, right? So we have a couple of states over here. We have number 1, number 2. We have our total, which is a computed value, which is the result of number 1 plus number 2. We're going to create an input and bind its value attribute to number 1 with our input options. And we're going to create another input and bind its value property to number 2. We're going to create a span, which is the result of number 1 plus number 2. And we're going to bind its text content property to the total, which again is a computed value. And then we're going to append them to this, right? Framework looks pretty simple, nothing too pretty, but nothing too ugly either. And this actually works if we set this thing to like, this over here. We see everything dynamically changing. This is super, super quick and reactive. This is super efficient. It's generally a really fun time. But the question is, how does bind work? And bind takes advantage of our reactive properties. So let's go through the code really quick. Bind, again, it's a method, so actually have a reference to the element over here. It takes a name, and we have some code over here which checks if a name is a value. Value is a special property, so it's nicer to use over here. We get a function or reactor. We're trying to get a reactor over here. So if it is a function, we change it to a reactor. Let me just change. Did I use any functions? No, I just only use reactors here. I'm fine. Let's open framework.js. And if it is a value, we add an event listener to the input, where in response to value being changed over here, we change the reactor itself. And then in response to the reactor changing, we can change this value. So we have a double binding. Either the reactor changes and this value changes, or this changes and the reactor changes. With text content, it's only a one-way binding because, text content itself can't change the reactor. And then same thing over here with just set attribute. So this isn't too difficult to explain. The code it should be in the article as well, so you can kind of see how it was done if you want to look a bit more in depth over here. But we can sort of see how we're using these reactive principles to create a framework which has values react to one another. And when it comes to HTML in the DOM, we kind of really want reactive data to happen all the time. It's super, super useful for so many use cases, and just using it like this makes our job so, so, so much easier without having to have some sort of parent-child relationship. This is just input options, my own custom little idea for a framework, which is called a reject on and a mutator, where the value changes from a string to a number, and it rejects on if it's not a number. So is not. And this is just not super related to the code we're discussing over here. Again, I really hope you enjoyed this tutorial. It's a bit more long form, and using branches in Git was a bit of a weird way to do this, but hopefully it made some sort of sense to you guys. Let me know in the future if you would like some more different things, what you did or didn't like, and I'd love to improve it for the future. Thank you.